Alright, boys and girls, welcome to our second video lesson in Chapter 8, 8-2, our lesson on arithmetic sequences and series. An arithmetic sequence is a sequence where we're adding the same thing or sometimes subtracting the same thing to get to the previous terms. The thing that we're going to add each time is called the D. We can always find the D by subtracting any two consecutive terms in the sequence. So a sub 3 minus a sub 2 is equal to D. A sub 2 minus a sub 1 is equal to D. And a sub n minus a sub n minus 1, the previous term, is always D. The nth term of an arithmetic sequence is a sub n is equal to dn plus c. This is actually just a linear function, where c is equal to a sub 1 minus d. Or you can say a sub n is equal to a sub 1 plus d a whole bunch of times. That number of times that we're going to add d is always one less than the term that we're on, or n minus 1. We'll go over this in class, but remember, an arithmetic sequence is a linear type function. The sum of a finite arithmetic sequence, we also call the sum of a finite sequence a series, of course. The formula for an arithmetic series is S sub n, or a series, is equal to n divided by 2 over the first term plus the last term. And I will go over the derivation of this formula in class. It's actually pretty groovy. Okay, so if we look at this problem right here, we're asked to find the sum of the first 10 integers from 1 through 10. So what we're saying here is that's 1 plus 2 plus 3 plus 4, it's a 4, all the way up to plus 9 plus 10. If I add all those up, I'm going to get 55. Okay, the summation form of this is going to be the sigma n equals 1 to 10 of n. In other words, our arithmetic rule is just going to be n. We can also use our formula now. So S sub n is equal to n over 2 times our first term, a sub 1 plus a sub n, which now equals n is 10, so 10 divided by 2 is 5, times our first term, which is 1, plus 10, our last term. 1 plus 10 is 11. 5 times 11 is 55. And you can see now we get the same answer. Okay? If I want to do the second one, numbers 1 through 20, again, S sub n is going to equal n over 2 times a sub 1 plus a sub n. So if I want to add up all the numbers, 1 plus 2 plus 3 plus 4 plus 5 plus 6, all the way up to 20, I'm going to get, our n is 20, so that's 20 divided by 2, times our first term, which is 1, plus our last term, which is 20. 20 divided by 2 is 10, times 1 plus 20 is 21. So this series is equal to 10 times 21, which is 210. Okay, you guys figure out the sum of all integers 1 through 100. Remember, if we want to write this in sigma notation, n equals 1, we're going to go up to 100. Okay, and our rule is just n, because our first term is 1, our second term is 2, our fifth term is 5, etc. Okay, remember, we're going to do n over 2 times a sub 1 plus a sub 100. Go ahead and figure out that answer. Okay, let's try this one. All integers from 100 through 1000 inclusive. In this case, be careful now, n is not going to be 1000. We need to subtract 1 through 100. So we're going to get 900. But we actually want to include the 100, so n is going to equal 901. In other words, from 100 to 1,000, including 100 and 1,000, we have 901 numbers. So we're going to write here, S sub n is equal to n over 2 times a sub, in this case, a sub 100 plus a sub 1,000. Well, again, we have 901 numbers, so that's 901 divided by 2 times a sub 100 is 100 plus a sub 1,000 is 1,000. We now need to add 100 plus 1,000 is 1,100, and we're going to do, and I'm actually pulling out my calc here, 901 divided by 2 times 1,100, and we should get 49550, and that was a 4. Okay, for a bonus point, the first 5 people to send me the correct answer of the sum of all even integers from 50 through 100 inclusive get a bonus point. Okay, looking at this guy right here, this is just now we're back to a sequence. What are the first 5 terms of the arithmetic sequence? A sub n is equal to 1 plus 4 times n minus 1. Remember, we have the formula a sub n is equal to a sub 1 plus d times n minus 1. So we can see now that a sub 1 is 1. That's our first term. Our d, what we're adding each time, is 4. And the n minus 1 is the n minus 1 right here. So we already know now that our first term is going to be 1. Our next term, we're going to add 4, is 5. Our next term is going to be add 4, 9. Add 4, 13. Add 4, 17. And we can always check that by plugging back into our formula. For example, a sub 5 we knew was 17, which is going to equal 1 plus 4 times n, which was 5 minus 1. 5 minus 1 is 4. So 4 times 4 is 16 plus 1 is 17. So it worked. Okay, and this guy right here, our first term, a sub 1 is 15. So we're going to write the first 5 terms. Our first term is 15. Our d is 4, so we're going to add 4 each time. That's 19. Add 4 to the next one, that's 23. Our next one is plus 4, 27. And our last term is 31. There are our first 5 terms, 15, 19, 23, 27, and 31. Our rule is going to be a sub n is equal to a sub 1 plus d times n minus 1. Well, in this case, a sub 1 is 15. Our d is 4. So I have 4 times n minus 1, which if I distribute my 4, I get 15 plus 4n minus 4, and you can see now that a sub n is a linear function, 4n plus 15 minus 4, 11. So our rule is a sub n equals 4n plus 11. Alrighty, we got an arithmetic term defined recursively. Notice again, we start with our first term, a sub 1 is equal to 200. Our next term, I'm going to take my previous term, which is 200 now. So a sub 2 is equal to 200 minus 10, which is 190. A sub 3 is equal to 190, the previous term, minus 10, which equals 180. Our fourth term is going to be 170. Our fifth term is 160. If I wanted to write this rule, a sub n is equal to a sub 1 plus d times n minus 1. So our a sub 1 was 200. Our d was negative 10 times n minus 1. Running out of room here, that's parentheses. So a sub n, I'll switch colors so we can see it. A sub n is going to equal 200 minus 10n, I'm distributing the negative 10 here, and then minus 10 times minus 1 is plus 10. So a sub n is equal to negative 10n plus 200 plus 10, 210. And there is our rule. Alrighty, in this guy right here, find the nth term of this following arithmetic sequence, n is 50, so we're asked to find the 50th term. We're going to start by finding our rule. We know our rule is going to be a sub n is equal to a sub 1 plus d times n minus 1. In this case, a sub n, or a sub 1, is going to equal neg 6. We can see we're adding 4 each time, so our d is 4 times n minus 1. Let's distribute that 4. We get negative 6 plus 4n minus 4. It looks like our rule is 4n minus 10. That's a sub n. So now to find a sub 50, we're going to replace n with 50. So that's 4 times 50 minus 10. 4 times 50 is 200. 200 minus 10 equals, our 50th term is going to be 190. Alrighty, boys and girls, that's it. Have a great day, and we'll see you soon.